All right, let's say you want to fix your house a little bit. So let's say you had broken tile in your bathroom and your kitchen. Sorry about that. And you wanted to fix it. You need the same amount of tile to repair both rooms. Let's say you have 1/3 of a case of tile, but you need the same amount of tile in both rooms. We want to know how much tile is needed for each room. Well, remember now, you have 2 rooms. You have the bathroom, and you have the kitchen, and they both need the same amount of tiles. How are we going to figure out how much tile we need for the rooms? Well, since we're splitting this into 2 equal sections, that means we have to divide. So we have to take 1/3 and divide it by these 2 rooms. Before we do that problem, we will come back to it. Before we do that problem, let's go on to what it means to divide a fraction. So let's look at the following. Let's say I have 6 divided by 2. I know that's 3. Well, I'm wondering, what number can I multiply by 6 to give me 3? Just think about this for a minute. What could I do with 6 to get 3? Well, if I have 6 and I want 3, I could take half of 6 to get 3. And remember, of means to multiply. So half of 6 equals 3. I could prove it to you. 1/2 times 6 is 3. So I know I can take half of 6 to get 3. That's what it means. That's what multiplying by 1/2 means. It means taking 1/2. Okay, let's look at this next question. And this next question, 12 divided by 3 is 4. Well, I want to know, is there a number I can multiply by 12 to give me 4, to give me 4. Okay, let's take a look at this. Let's just take a look and see if the pattern works out. Here, it looks like I just put a 1 on top of this 2. Would a 1 on top of this 3 work? Let's make this 1/3. Let's just see if it works. 12 times 1/3, or 1/3 of 12. Well, let's take a look at it. 1/3 of 12. 3 goes into 3 once, 3 goes into 12 4 times. So it is 4. Let me tell you why that should make sense. Remember, we're having 3 equal groups of 12, 3 equal groups to make 12, not of 12, sorry. 3 equal groups that make up 12. 3 equal groups that make up 12. There's 2 groups, there's my 3rd group. There's my 3 equal groups that make up 12, and I'm taking 1 group of them, so 1 group of them is 4. So that makes sense. So let's look at the pattern we have. We have 6 divided by 2 equals 3, which is the same thing as 6 times 1/2. This is the same thing. Let's just do one more example. Let's say I have 15 and I want to divide that by 5. If I will have 15 and divide it by 5, that's 3. Well, then 15 times what number should give me 3? Okay, notice what we did. 2 went to 1 over 2. 3 went to 1 over 3. Okay, so 5 should go to 1 over 5. And I could multiply and show you that's true. Right now, I want you to just take my word for it. Okay, so here's what I know. I know from this, dividing by 2 is the same as multiplying by 1/2. I know from here that dividing by 3 is the same as multiplying by 1/3, right? And finally, dividing by 5 is the same as multiplying by 1/5. So let's talk about these numbers. 10 divided by 5 asks how many 5s are in 10, right? 10 divided by 5 is 2 because it asks how many 5s are in 10, and there are 2 5s in 10. Let's talk about what 3/4 divided by 1/8 says. It says how many 1/8 are in 3/4. Okay, how many 1/8 are in 3/4? And I'm going to prove this to you. Watch. Okay, so how many 1/8 are in 3/4? So I'm going to take 3/4. You know, because I had to use these again because they're just so colorful. Okay, how many 1/8 are in 3/4? Look, I'm accumulating caps, but not pens. Okay, now I'm going to take the 1/8. The 1/8 were the blue guys. Okay, I'm going to see how many 1/8, little guys, make up all of that. Okay, so let's see. I'm going to count them when we're done, when we got them all set up. All right. Oh, look at that. I lucked out. Picked just the right amount. Okay, so I know that 3/4 divided by 1/8 is 1, 2, 3, 4, 5, 6, because there are 6 1/8 in 3/4. Okay, so let's take a look at how we can put everything we just said together. Okay, so let's look at this question, and we'll write it out, and we'll try to do it. We're going to do from scratch 3/4 divided by 1/8. Remember we said before that dividing by 2 was the same as multiplying by 1/2. Okay, and we said dividing by 3 was the same thing as multiplying by 1/3, and so on and so forth. Let's take a look at this. I'm going to leave this on the board because I'm going to need it in a minute. But let's take a look at this number 2. I'm going to write it as 2/1 so I can see it as a fraction. I'm going to write right underneath it 1/2. So dividing by 2 was the same thing as multiplying by 1/2. Dividing by 3, I'm going to write it as 3/1, the same as multiplying by 1/3. Okay, let's take a look at these numbers, the relationship. This is 2/1, and what I have here is 1/2. All we did was take this fraction and interchange the numerator and denominator. And when we did that, we formed this fraction, and these are called reciprocals. Same thing here, reciprocals. Reciprocals are formed, and this is in your notes, reciprocals are formed by interchanging the numerator and the denominator. So dividing by some number is the same as multiplying by its reciprocal. So let's take a look at this problem. That should help us solve this. We already know what the answer is. It's this. It's 6. We already did it. But let's see how it's done mathematically. To divide, you keep the first fraction, and you, instead of divide by that number, you can multiply by the reciprocal. So we're going to multiply by the reciprocal of this number, and the reciprocal is formed by interchanging the numerator and the denominator. So this becomes 8/1. So again, when you divide, you keep the first fraction, change division to multiplication, and you multiply by the reciprocal. So you flip this or interchange the numerator and denominator. And when I do that, I can reduce. 4 into 4 goes 1. 4 into 8 goes 2. 3 times 2 is 6/1. 6/1, but 6/1 is 6, which is exactly what you should have gotten. We saw that here. Okay, so before we do any more problems, let's make sure you understand this concept of reciprocal. Okay, so take a look at your workbook and just find the reciprocals of the numbers that are there. And I want to say something else about the reciprocal, but we'll do that in a second. All right, let's see what you did here. All right, remember to make a reciprocal, all you have to do is interchange the numerator and the denominator. So 2/7 becomes 7/2. Now let's talk about this for a second. When you have a number and its reciprocal, the product of a number and its reciprocal is 1. So that means when I multiply these two together, I must get 1. I'm just going to show you this off right here for a second. 2/7 times 7/2. Good night. We get 1. Good night. So that is 1. So notice, when you get the reciprocal, you actually use the same sign, just interchange the numerator and the denominator. Okay, so let's look at -4/3. All we do is interchange the numerator and denominator and keep the negative sign. Where do I put the negative? Remember, it doesn't matter. And again, their product is 1. A negative times a negative is a positive. The 4's will reduce, the 3's will reduce. Or you can multiply across 12/12, which is 1. To do this one, I would make this look like a fraction, and then I'd interchange the numerator and denominator and keep the sign, so that's 1/7, -1/7. This next one, interchange the numerator and denominator, we get 5/1, And again, the product is 1. All the answers down here are 1. Okay? This next one. Oh, by the way, if you want, 5 over 1, if you'd like to just write that as 5, you can. It doesn't matter. This one here is interesting. 0. Remember that its product is 1. What can you multiply 0 by to get 1? Nothing. So there's nothing I can multiply 0 by. So it has no reciprocal. I'm going to prove it to you another way. If I have 0 over 1 and I flip it, I'm going to get 1 over 0, which is a number that does not exist. That's undefined. So 0 has no reciprocal. Remember, it has an opposite. The opposite of 0 is 0, but it has no reciprocal. It is the only real number without a reciprocal. Okay? All right. So let's do some division problems and see if we can understand them. All right, let's take a look at this. Remember, we just said dividing is the same thing as multiplying by its reciprocal. So 2/3, we keep the first fraction, we change the division to multiplication, and we interchange the numerator with the denominator, therefore making its reciprocal. All right, so now we multiply. I'm going to reduce. 3 into 3 goes once. 3 into 6 goes twice. 2 times 2 is 4. 1 times 1 is 1. 4 over 1, or just 4. So it's really pretty simple. Keep the first fraction, change division to multiplication, and flip the second fraction. So it's really kind of cool if you knew what you did before when we multiplied. Now we just changed division to multiplication. Okay. Let's take a look at the challenge problem. Now remember the problem from the beginning? I know that problem. It was, we had this 1/3 of a case of tile. We're dividing it by the kitchen and the bathroom. So we were taking 1/3 and dividing it by 2. Okay, so let's do that. We're going to take 1/3 and divide by 2. Well, in order to do that, I want to make everything look like a fraction. So this is 1/3 times 1/2, because I'm going to flip this fraction, right? Keep the first one, change division to multiplication, and flip this one. When I do this, I get 1/6. So everybody gets 1/6 of a case of tile. Okay? So that's how that works. So this whole thing, this whole discussion was based on this little thing about this case of tile. First you had to learn how to divide in order to get to the answer. Let's do a couple of questions. I'm going to let you do the first 3, and then we'll check on your answers. Okay, let's do the same thing we did with multiplication. Let's take care of the sign first. This is a negative divided by a positive, which is a negative. Now I'm not going to deal with the sign again. Okay, so that's going to be the answer. And we have 5/7 divided by, changes to multiplication, 21 over 4. Again, negative. Okay, for my answer. I'm going to reduce if I can. I can't reduce this way. I can't reduce this way. Can't reduce this way. But yes, here's a winner. Okay, 7 goes into 7 once. 7 goes into 21 3 times. So that's 5 times 3, which is 15 over 4. Now you can change that to a mixed number, but to be honest, in algebra, we like improper fractions better than mixed numbers. So I'm going to leave that -15/4. Okay, let's take a look at number 2. It's division. Now don't go flip crazy. Only flip in division, okay? Only get the reciprocal in division. This is 0, which I'm going to write as 0 over 1. I can write 0 over anything I want and it'll still be 0. Our division is going to change to multiplication. We're going to flip this, -5/3. Now, to be honest, this is 0 times this, which has got to be 0. If you want me to do it the long way, I will, but it's got to be 0, okay? Because 0 times anything is 0 over 3, which is just plain 0. But I knew that from the get-go. All right? Let's take a look at this. I'm going to write -6 over 1, which is -6 over 1. Division changes to multiplication. -7/6 becomes -6/7. Signs are the same, so the answer is going to be positive. I cannot reduce here because I can't reduce this way or this way. Remember, I'm not allowed to reduce this way. So we get 36 over 7. 36 over 7. Done. Okay? Let's make them a little harder. Let's look at 4. You know, I want to leave those incredibly straight lines. I'll just leave it like that. All right, 4 says 3/7. divided by 0. I'm going to move this over, I think. Ah, see, I didn't really leave it. But I actually want more room for these. 5, 18 over 7x divided by 6x over 7. And then finally, 6y over 8 divided by xy. Okay. Well, this is up to you, but I'm thinking we're dividing by 0. Remember, we're not allowed to divide by 0, so this is undefined. If you don't see it, watch what will happen. I'd have to write this over some number, and then when I flip it, it doesn't exist because it's undefined. So I don't have to do anything here, but understand this is undefined. Okay, so 0 over 1 is not in any sets of numbers because it is undefined. It does not exist. Okay, let's try this one. 18 over 7x, division changes to multiplication. 7 over 6x because I flip. Okay, let's reduce. Oh, I'm seeing lots of reducing possibilities here. Okay. 6 goes into 6 once. 6 goes into 18 3 times. Now we got the 7s. Good night, 7s. So we got 3 on the top. And we got x times x, or x squared. If you wanted to do that straight across the multiplication, because you might have thought it was easier because you have variables, you could have. I just thought the numbers were going to get way too big, so I didn't bother doing that. Okay? Last question. Let's look at this. Y over 8 divided by, I put this over 1, so it'll be a fraction. I'm going to flip it because I need the reciprocal. Oh, forgot to change it to times. Let's change that to times, multiplication. Now, this is up to you. This is absolutely up to you. You might want to reduce here. You might not want to. Remember to reduce. I can reduce a numerator with a denominator. There's not a lot of stuff going on here, so maybe I'd reduce. Good, but it's up to you where you want to reduce. It doesn't matter. Y goes into y once, so we have 1 times 1, which is 1. 8 times x is 8x, times 1 is 8x. That's a terrible 8. Okay, so 8, that's even worse. Okay, 8x. I should probably stay away from the number 8. Anyway, 1 over 8x is your answer there. Okay, last question. We have x divided by the quantity yz. I really don't like the division sign, but that's what's in the problem, so I'll leave it there. And it says x is negative 4/7. Oh, this looks fun. Y is 4/5. Z is 3/7. Okay, just in case you didn't like fractions, too bad. Here we go. Okay, remember, this is substitution. Keep all the original parentheses in the problem. So x is negative 4/7 divided by, what I'm going to do here, here's the original parentheses. And now here's a parentheses for y, here's a parentheses for z. Y is 4/5, z is 3/7. And I'm going to get rid of this x, y, z because it's looking pretty sloppy here now. Okay, so that's what I got. Order of operations says parentheses first if there's an operation inside. There's no operation inside here, but there definitely is in here. This looks like a mess. Let's take care of it. So remember, when you multiply, there's no flipping. Don't go flip crazy. This is just negative 4/7 divided by, okay, I'm going to let go of these parentheses because I'm multiplying. That's 12. I can't reduce. 12 over 35. Now, actually, neither one of these parentheses are necessary. I'm going to do that here. So that's negative 4/7. Division changes to multiplication. And now I have to multiply it by the reciprocal. So I interchange the numerator with the denominator. Now, what I would do is take care of the sign. The signs are different. This is negative. This is positive. Now I'm going to reduce. 4 goes into 4 once. 4 goes into 12 3 times. 7 goes into 7 once. 7 goes into 35 5 times. 1 times 5 is 5. 1 times 3 is 3. Again, an improper fraction. Who cares? All right. And that takes care of division of fractions. Next, we're going to add and subtract them.